Today, you're gonna implement the WebSocket protocol from scratch using only Node.js and JavaScript. You get to know what are bitwise operators for handling binary data in JavaScript, how to debug them, and how different they are from numbers. You create a complete web server that receives and sends data without any framework or library. Understanding of how the WebSocket protocol works and how you can explore advanced concepts in practice. I built an interactive spreadsheet as a map so you can easily find where the data is. I'll show you how to handle buffers and encrypt data and decrypt data using nothing less than what the WebSocket protocol requires you to do. In the end, I'll give you some challenges to go further and extend this application. Hello my friend, welcome to my video. I'm Erick Wendel and today we are gonna build a complete WebSocket application, client side on the browser, server side on the Node.js, using only the Node.js built-in modules. No frameworks, no libraries, no socket.io. Just the raw Node.js implementing the WebSocket protocol, handling bits and bytes, inspecting sockets, and respecting the whole protocol while establishing connections and exchanging messages. I would say this is the first content ever teaching about WebSockets from scratch with JavaScript and Node.js on YouTube. So send this video to all your colleagues and let's begin. Are you excited about this video? I am excited about this video. Well, get a drink and let's begin. Before moving on, please don't forget to press the like button. It helps me a lot with the work I've been doing on this channel. You can also suggest what you want to learn by commenting here on this video. If you're not subscriber yet, subscribe now so you won't gonna miss all the content I've been publishing here. WebSocket applications are usually applications that work with real-time connections, such as chats and interactive dashboards. We usually have connections between one server and many clients. When something changes on the server side, all the connected clients are notified and receive the data as soon as possible. The goal today is to use the Node.js modules to implement the WebSocket protocol from scratch and understand the lifecycle, encryption, and how to exchange data between many connected clients. You get to know how the bits and bytes are flowing during connections and why people love so much how the current libraries abstract all the complexity when working with WebSockets, such as socket.io and WS. I love doing this kind of experiment, reproducing web APIs, web protocols, and cloning existing applications from scratch. I learned a lot in practice. How is the magic those packages have been doing for so many years? I was researching references about WebSockets in Node.js without socket.io and other packages, and it's pretty hard to find articles or videos on the internet about it. I've already done a video here on the channel about building a complete web API with no libraries and frameworks, but the WebSocket subject was much harder than I thought. I was researching on the internet and surprisingly, I couldn't find any example using Node.js that was compatible with the browser API. I actually got a Mozilla Developer Network article that was explaining what you should do if you want to implement it, but there are no examples. It's just a step-by-step of the specification. Well, I'll tell you, I couldn't find anything about Node.js, but I found a lot of people complaining on the Stack Overflow that you shouldn't write a WebSocket application from scratch because it's too hard. Then I thought, well, if it's that hard, it will be at least a good challenge, right? And then I figured that I should look for examples in other programming languages. I found one of the best resources on the internet with code examples. This one was something very close of what I was planning to do. In this post, the author is using only the Ruby built-in methods to build a WebSocket applications that follows the WebSocket protocol handling bits and bytes as I wanted to do. The only problem I found here was that Ruby has different methods to handle binaries in comparison to Node.js. I was trying to translate the calls using Node.js. However, I don't know much about Ruby, so I ran the app from the tutorial, put some logs, and I was checking what my application should look like. I had almost everything working except my messages were encrypted and it wasn't sending message to the clients properly. I figured that Ruby has native modules to handle bytes and to convert numbers that doesn't exist in Node.js. At least they don't exist with the same name. Well, I got stuck, so I started looking at how the actual Node.js libraries do. I went to the socket.io repository on the GitHub and I found it pretty hard to understand. Although, when I got to the WS package on GitHub, I found two interesting files. The way they implemented the protocol was much easier to understand than socket.io. However, I still found it pretty hard to understand what all those magic numbers and binary codes were doing there, so I tried to use a few ideas from their code and implement my own idea. The first thing I did was to read and make notes of how the payload should go in and out of my application. This actually helped me a lot. I'll share this document with you later. I think you're gonna love it. The hard part for me was trying to figure out how the Node.js platform handles binary numbers. That binaries actually are integers that are parsed behind the scenes using bitwise operators. And honestly, I've never worked with bitwise operators before. And don't worry, I'll get into those topics when we were building our application. Those concepts scared me in the beginning, but how they actually work is pretty straightforward to understand. Before I move on, you may be asking, Eric, why should I implement this network protocol from scratch? Haven't the libraries such as socket.io done enough? Well, I know that in production environment, we'd use the socket.io or its competitors. However, this kind of experiment gives you the power to understand advanced concepts beyond your current skills. It lets you understand what those libraries do in the background. In case you find some problem, you can either fix the library or discuss with your team strategies to fix it. You know where exactly the problem is and what is the expected behavior. For our project, I will use the Node.js 18 in a single HTML file that will exchange messages with our server back and forth. I've spent so many hours building this video for you, experimenting and trying to make the example straightforward to you. Please tell me here on the comment section what you find about them. If you have any questions, please use the comment sections that I will answer all your questions, okay? Start talking about what WebSockets are. I think it's a good thing to get a brief introduction, and then I'll go deeper and deeper into implement all the ideas, okay? Imagine that you need to list products in your e-commerce app. The front-end application that is running on your cell phone requests the e-commerce's web service. The communication between your cell phone and the web service is established on the top of the TCP protocol. The TCP is the main communication protocol of the internet and the communication protocols. The acronym TCP stands for Transmission Control Protocol. TCP provides reliable, ordered, and error-checked delivery of a stream of bytes between applications. TCP is connection-oriented, and a connection between client and server is established before data is sent. A server host must be available to receive new connections from clients even before a connection is established. The vast majority of applications, such as websites, sending mails, or transferring files, run on the top of the transport layer of the TCP/IP suite. Back to the case of our cell phone trying to display a product list. To access this data from the web service, you usually make an HTTP request. HTTP is an application layer protocol that runs within the TCP/IP suite. HTTP functions follow a model called request response. When you go to your browser, you type an URL, the browser sends an HTTP message to the server. The server responds to you with HTML files, messages, the content itself. Supposing that it's just a request and response model, what if I need information that is constantly being updated by the server? I should create like an infinite loop on the client side that keeps hitting the server getting those updates, right? There is a technique called HTTP polling. It was pretty common to see applications using this kind of approach, but it's pretty expensive and could cause server overloads. The best way to handle data that is constantly being changed is, instead of requesting a lot of the server, is just to upgrade the connection and keep it alive. This is where the main protocol for real-time communication comes in, the WebSocket protocol. The WebSocket protocol came to fix the problem of the request and response module. Now, the server and the client can exchange messages over a single TCP connection and stay connected as long as needed. And without overloading the server as HTTP polling could do, which eases real-time data transfer from server to the client back and forth. Both WebSocket and HTTP depend on the TCP protocol. To achieve this HTTP compatibility, the WebSocket protocol uses what we call HTTP upgrade headers, used to change the protocol from HTTP to the WebSocket. And finally, here begins our journey in building WebSockets from scratch. I just gave you a brief introduction because we are gonna use the native HTTP module on the Node.js platform, and you notice this connection upgrade, so everything will make even more sense to you. And not theory, right? Let's now open our code editor and start creating our Node.js server and web client right away. Well, here I'll show my Node.js version, so I'm using 18.4. It's cool for you to use the same version as me, so you won't be facing any error or any different breaking change, okay? Well, to start, let's create a folder. I'll call it as Node.js raw WebSocket. And I'll create two files, the index HTML and the server, and I'll call it MJS because it will be a ECMAScript module, so we can use import, export, and etc. Okay, so I'm gonna also install the nodemon. The nodemon will be cool for us to restart our server as we change this server. Okay, perfect. I'm gonna start with nodemon server on the folder, so let me open the folder, and here nodemon server. Okay, both of them are empty right now. Well, how do you create a server in Node.js without any express or any library? Well, we're gonna use basically the HTTP module. So I'm gonna call create server, and I'm gonna just run request response. I'll put here to listen to a port, so the port I will define here. Well, I will use on 337, and then after it's running, I can put like a console.log server listening to port. Okay, so I just saved, and it seems our server, it's okay, it's running. So when someone try to read this port, I'm gonna just respond with right hat 200, and then I will just say hey there. Okay, so if you open a browser right now, you can check on this port, it's 1337. Okay, hey there, so we have everything set for our server, right? Very straightforward with Node.js, isn't it? Well, something I like to do here is prevent some problems on the Node.js. So if we have any exception, we just gonna log it, but the server will still open. So error handling to keep the server on. So I'm gonna listen for just two events. It will be well, actually, we could go with process dot on, and we have all of the events here, right? So I'm gonna get this uncaught exception. I'm gonna copy paste here. I'll do the same to get the name of the other. Will be unhandler rejection. Perfect. Well, every time we see these events happening on the Node.js, I will just call this event. I will break a line here, and I will move this process.on here, and I will put our event there. Okay, then we have the error, and then I will put something like console.error, something bad happened, event, and the error we can put here message. Well, it will be either the error or the stack. Oops, it's two pipes. Perfect. Just make sure the server is still on. And let's see, we have like a throw new error here. Throw new error. We should see this events working. So let's go back to the browser, send it there. As we are not sending anything more, but we should see the logs here. Okay, well, we won't use much this endpoint, so I won't do anything here. So the error randomly will be actually to the other things. Okay, as our server is working fine, let's go back to the HTML file. Right here, I will just type HTML5, and the VS Code has something here. I will show like WebSocket client, Erick Wendel, so you can put your name as well. Perfect. Here, I will have just a script and output, okay? I won't focus in any layout here of just connect and send messages back and forth, okay? So messages, perfect. So first, I'm gonna have here the messages, okay? So document dot get element by ID messages. And then to create our connection, it's pretty straightforward. What we should do, we should use the WebSocket. The WebSocket, it's an API on the browser, so most of the browsers have this one. So I'm gonna put new, and we're gonna use the WS to say it's insecure, HTTP, or without any HTTPS, without any encryption connection. And then we use our URL. So it's 1337, right? And then I will put some events here. So we have the socket on open, right? Then we're gonna use on message, and then we're gonna use on error. And we can also use on close to get to know when it's closed or not, okay? So first, for on close, when a connection just closed, I'll put here console.log disconnected from the WebSocket server. Okay, for the error, I will put the same idea, but here we're gonna receive the error, right? The error here, I will put it as error. So WebSocket error, and then I'm gonna use just this message, okay? Well, when we have a message, we actually can reuse this. I just say I got a message, and then the event here. It will be actually the message itself. Okay, and for on open will be very similar. We're gonna have the event here, and I will put here just WebSocket is connected. Okay, so we're gonna have all these events right now, and then we have to go back and implement those functions on the backend side. Okay, well, it's nice to see how the browser handle all the complexity, right? We're gonna implement on the backend and gonna see how complex it's just this class and how it's good to use it as well. Okay. All right, to see if everything's working, we can just drag and drop this function in another tab. As we can see, we have nothing there, but if you go to the console, you can see that Firefox couldn't reach our server, right? So our server are not following yet the specification. We can see a generic error here, because our server is not a WebSocket server yet. It's just an HTTP, and then we have to move forward. Just a matter of checking if the browser is actually sending what we need. I'll put here server, okay? And then I will just listen for an event upgrade. Okay, so we're gonna check if the browser is sending events, if it's actually working fine. Well, when an upgrade happen, we have the request, the socket, and the headers. I'll just put a console.log here and log everything we got, just to see if the browser is okay, if everything is working as we expect. I'll go back to the browser and I'm gonna update this file. Well, we haven't seen anything different here, right? But let's see on the backend side. Oh, on the backend side, we actually got the upgrade in all the data. So we must look after some data on these headers and everything else. Very nice. Now that our server is ready and making the connection upgrade, we should establish a handshake between the client and the server. Looking at the spec, the first thing we notice is that the client will send us a WebSocket key. This key will be used to accept a specific connection and to address an identifier for the client. Each client will have a different ID, and that's how you can send individual messages to specific clients. In order to finish the handshake, the server should respond with a specific header to accept the connection. For the response header, we just basically concat this magic string defined by the protocol, a very weird string in my opinion, and the client's key. Then we create a SHA-1 hash and return it as a base64 string. I would say this part was one of the scariest for me when looking at the docs, but I'll show it in practice and you notice that it's not hard as it seems. Going back to our project, we should see some logs on our returning here, but I would make it easier. Let's just get the headers here, okay? And remove everything else. So it just restarted. We go back to the browser and we updated the page. Okay. So I go back there. Oh, it's actually here. It's actually the buffer. We should get here request dot headers. I will update again and let's check it. Ooh, very nice. So right now we have those WebSocket key and a lot of other headers we're gonna need. But for now, I'm gonna get only this socket key. So let's get here. So it will be const web client socket key. So I'll get from there, but I'll do just the structure in here to make it prettier, right? So let's see if we got, oops, let's see if we got this message correctly. Just saved, updated the server, and let's see on our logs. Oh, there it is. Perfect. Right now on the description, I put there the whole string if you want to use, but also the docs. So let's open this same tutorial together. Okay, let's open there. Well, as I told you, here they are all what we should do, but for now, we just need this magic string, okay? So I'll just copy it and I'll put here. So const WebSocket magic string key. Just to know that this is from the spec, not something that we are generating, okay? Perfect. So right now I'm gonna work here and I'm gonna do something to make it better, right? So just gonna create on socket upgrade and I'll put here, oops, here, remove this key and let's put it here. We don't need this parentheses and I will log just that someone just connected because it's an individual ID, right? Because it's an individual ID. Okay, connected. Perfect. Here, I'll just remove this space. All right. Well, let's create another function. I'll put it right below. And I will call it as prepare handshake headers, and I'm gonna need this ID. What is the goal? Is to follow this doc, right? So we're gonna do the SHA-1 and then return it as a base64 without any frameworks. Perfect. So to do this, we just need the crypto from Node.js. So I'm gonna call crypto from crypto. Okay. All right. The doc said that we need to concat this string, right, with the client socket key. So how do we do that? All right. So I'm gonna create another one here, just to make it easier to read later. So I'm gonna call it as create socket accept, right? And then here we can make the calculations. I think it's easier if you wanna go back and check what's doing and so on. Okay, with crypto, we first need to create the hash, right? So we're gonna create hash. Which algorithm? SHA-1, right? As the spec shows us. So I will call it like SHA-1 or SHA algorithm. And we're gonna run the update. So the update, we will need the key, right? So it's the ID. And then we're gonna use the magic string. Just it. Very straightforward, right? And then we're gonna get this SHA-1 and return it as a base64 string. So it's base64. Perfect. So here I'm gonna call the accept key. I'm gonna grab ID, and then we can just call our function. So I'll call headers equal handshake headers, and then I'll put it here, and then we can log if the headers here. It's not actually the headers yet, but let's just see if we did any mistake or if it's working out. Headers. Okay, accept key. I will have just to return it so we can see the result. Perfect. So here, oh, there's a problem here. Oh, it's missing a function, right? So we're gonna just pass our socket upgrade, and then it's working out. Let's go back to the browser, to the client, and update it. So I'll go back to the server and see we have now, oh, very nice. Now we have the key that we must pass to our specification. Well, looking at the docs, you can see there are more things that we should do. Like we have to return all this thing here, right? In the same pattern. Well, I'm gonna copy everything here, and here will be actually the headers. So the handshake headers, I'm gonna put everything here to make it easier. I'm gonna put a string here, and at the end, notice, perfect. And this accept needs the key, right? So the key here will be just our accept key. And here I'm gonna put some commas. And I notice the last line has to be always empty, otherwise you're gonna find some problems there. Perfect. Well, we have to format as the specification demands. So let's do it. So the line, we're gonna get it. Each line, we're gonna concat with R and N. So everything here, we're gonna have some spaces and so on, and then we're gonna join them in a string. Okay, and now we have our headers. Perfect. Just sit. Well, now that we have our headers here, we just have to respond it, right? So I'm gonna just use socket.write headers. Right now, we should see our server connecting to our client, right? We should see some logs on the client right now. So I'm gonna save it. Just look if there's no error, and then go back and let's update it. Ooh, very nice. The WebSocket is connected. You can see the network here, everything like the upgrade was successful, how long it took, and a lot of other informations. But still, we don't have any response and everything else, right? But it's okay. Oh, halfway, we already gone through it. Whoa, how nice is it? Tell me here on the comments now. We just made our WebSocket connection following the WebSocket protocol using cryptography and following the connection upgrade. Now we'll build the function to receive the client's messages, and that's what people use to complain that it's too confusing and hard to understand. Well, I cannot blame them. Look how complex this table looks like. Translating to you, it means how the data is sent to both client and server. However, I found it too complex to understand just looking at this table, so I built mine. I think this table I built will help you to even write your code. I split it in different sheets. I'm gonna show you my table in a few, but just looking at these docs, I realized something. As a byte string is represented as continuous card from the left to the right, they made this table horizontally. The problem here is that the text is not continuous and there's no scroll on the view. For me, it was impossible to understand that as they break some lines. We are gonna go through this spreadsheet later as a guide to mark where the data is. I've translated what the protocol dictates for data exchange. I found that as a byte could be a long way to the right, I reversed it and did it from the top to the bottom instead from the right to the left as they did it. When sending data, we received it as a data frame. Data frame are basically arrays of bytes containing the whole request information and data payload. If you don't remember, a byte contains 8 bits, and that's why I divided into different columns with an infinite scroll to the bottom as the byte would be long. Looking on the WebSocket protocol, you may notice that each bit there represents something and shows us a path about where to look after the data. Well, I won't try explaining this whole spreadsheet to you now. Let's start implement our data receiver, and then I'll go back on those positions to use our code. Okay? Well, if you've worked with Node.js streams, you have noticed that sockets are basically Node.js streams. If you've never heard, there's no problem, you can watch my video here later about this subject as well. But basically, this socket, we receive events. So from these events, we can get either requests, we can see when a client is ready, or even get those bytes I told you before. Well, to do this, let's create another function here, and I'll call onSocket readable. So when it's ready to read data, okay? So I'm gonna just put here socket on readable, and then I'm gonna use this function. Perfect. Well, I think we're gonna use the socket for it. Sockets. As you notice, there are a lot of sheets here, and those sheets means the size of the messages, okay? So when a client is connecting to the server, it's required to be masked, okay? There are some encryption data when they use the client ID as well. I'm gonna go through this subject later, okay? But for now, let's just go to the masked here, okay? And then we have to see some informations right here. Well, the first byte represents some informations. So the thing is just to check if either this is the last message. I put some description here if you wanna take a look later as well. Okay, and the opcode just saying if it's a text data or either is a binary and so on. Okay, so first we don't need this information right now. Okay, so I'm gonna consume the first byte and just remove it. To consume the first byte on the Node.js, consume optcode, the first byte. Okay, we're gonna use just socket read and I'll pass just 1. Okay, so I'm not using this first byte. Okay, if you go there, we can see more and more data, more and more information there. As I said, every sheet here means the size, right? So here on the payload length, we can see some codes. So here there are actually what they mean. If they are 1, 2, 5, they actually are the length of the message. Okay, so we're gonna start from there. So if they are 1 to 5, it means they are 7 bits. Okay, otherwise they're gonna be 16 bits and it's another code. But let's focus on this first one and then we're gonna go through the others. Okay, perfect. Well, we need to know now the size of the application and those codes, right? So I'm just gonna copy the both of codes here. I'm just gonna copy this code and I'm gonna put it here as constants, right? So here, const, it will be 7 bits integer marker. Okay, then let's copy 1 to 6 and 1 to 7. Perfect. Okay, 7, and then the other is 16, right? And the other is 64. Okay, but in this class, we're gonna go through those two, and you have the challenge to figure out the last one. Okay, it's the same idea, but it's good to practice. Perfect. First, we have to figure out what is the size of our application, right? Our size. First, we have to check what's the size of the payload. Perfect. So how do we do that? Well, we're gonna read more one socket. Okay, socket.read 1. But now the 1 means a byte, right? So I'm gonna put here 1. It's 1 byte. In 1 byte, it's 8 bits. Just you can remember. Perfect. So it will be here we're gonna have all the bytes array that we have, right? So for each byte, it goes as a position on our array. But as I'm requesting just the next one, it will go just from this size. Okay? Perfect. So I'm gonna read, when I use read 1, I'm gonna go now from the second because we actually consume the first. So as much as we use the read function, it will gonna consume more and more bytes. Perfect. So what they said, if it's like 1 to 7, the value it's contained from the 1 to 7, right? Well, when you look at the docs, they said that the mask indicator here says for us always if our data is encrypted, but it's like a constant. So we can actually remove it from our bits and we can get the result, right? So how do we do that? I will put here more one constant. If it's a bit confused, don't worry, we're gonna go there. Well, the doc says that this mask indicator has only 1 bit. Can you see here? There is from 0 to 7, but you can see they're using only one position here, right? So this is a constant, so we can actually ignore this for now. How do we do that? We must know what is 1 bit in JavaScript. So let's go to our code, and I will just open a new terminal here. Okay, how do we know how much is 1 bit in JavaScript? Well, do you remember that 1 byte is 8 bits? So first I'm gonna put 1 and I will put 7 zeros. 1, 2, 3, 4, 5, 6, 7. Okay, I'll put it as string. Okay, and then I'm gonna use the parse int to convert this binary code from binary to a decimal. So I'm gonna use 2, and then we get this magic number here. Oops, we get this magic number here. Okay, so this is how we're gonna use it. So this was a bit confusing for me, right? Because we are using like those numbers, but actually what we are handling is binary codes. Oh, I'm gonna put here just a reference, right? So const first bit, okay, and I'll put it as 128, right? As we figure out here. Perfect. So we must remove the first bit from the second byte. So here we have the second byte because we already read one and we are gonna read the second one. As we are reading just one byte from the socket, it will return an array with just one position, right? So here we have the marker and the payload length. Oh, I'm confused. Why we have two informations here? Look, when we get a byte, we have 8 bits, right? When I do read 1, I actually got this whole thing here. So I get this whole thing and I'm removing the first one, okay? To remove the first one, you know, right? So I'm gonna write here, length indicator in bits, so you know what I'm talking about. I'm gonna get this marker and I will just remove the first bit, okay? So I'm gonna just put what is in the docs, like because the first bit is always 1 for client server messages, you can subtract 1 bit, or we call it's 1, 2, 3, 4, 5, 6, 7, right? 8 bits here from this byte to get rid of the mask bits. Perfect. I will put it here. I know that is a lot of information, right? But as long as you are following me here, you can check with the results later. Perfect. Well, I'm gonna create a variable here. We're gonna use it later, but I'll put it here just right now. I'm gonna get actually the message length first. So we must figure out which value it's coming there, okay? We actually can stop our code here and we can debug if we want. So I'm gonna put a breakpoint here and press F5. It will start, you can see listening here, and we can go back to our browser and update it. Well, I had to update twice, but it goes there. Well, here you can see all the values that we have, the socket and the indicator in bytes. So the length indicator here is 2, right? And the marker is 120, and the first bit is actually 128. Well, we can actually assume that if our length indicator in bits is 2, back into our spreadsheet, we can see it's less or equal 125. So if it's 125, now if we reach this condition, this is actually the length of the message, okay? Perfect. But actually, we haven't sent anything right there, right? What we can do is actually on our client, we put them to just send a message because we are just getting the ping there, okay? So after we connect, I'll put this console log here. And then let's generate an ID just to fake some data. Math.random, oops, round first, math.random. And then 0 to 100, okay? Well, I'm gonna put here console.log sending ID, and then I can put the data here and we can just make some fake object here. So I'm gonna put the ID here, name, the name could be, I don't know, a string, with the ID, Erick Wendel. You can put your name if you want. Address, just to check if we can send and receive complex objects. Street, I don't know, my street. Number, I'm gonna put like 20, just to generate data, okay? Profession, profession, developer. Well, as we have the data right now, as we have the socket ready, we can just run socket.send and actually send our data. Perfect. Oh, perfect. So I'm gonna save it. I'm gonna restart our server right here because it was stopped on a breakpoint. I'm gonna update our code, or see, like right now we got some data right there. Well, our marker for our payload is 236, right? But if we remove the first bit, we can see 108. So it's a 7 bits, right? So it's we go to the first condition here. If it's 0 to 205, this is the length of the message. Perfect. Right now we know where is the data. Right now we know where to look for. So right now we know in which sheet we should go. So if it's 125, it's masked and 7 bits. Why masked? Because a connection with the client is always obligated to be masked, okay? The server can send messages without masking it, but for the client, they must send the message masked. Perfect. Well, right now we have everything mapped, right? Here I put some example or how this byte array came there, and if you can parse radar, and that's it. Okay, we have the mask indicator. The mask indicator, if it's 0 or if it's 1, we can check if we have a mask key, right? So this mask key we're gonna use to decrypt or decode our data. So let's try getting this mask key because we know the browser we send data always masked. Perfect. I'm gonna go with play here. And then I will just make the checking, right? So length indicator in bits. If it's less than equal the 7 bits marker, okay, the 7 bits marker is 125. Okay, the message length will be actually the payload itself, right? Perfect. For now on, I will just put an error here. So if something, someone sent something bigger, I will just throw an error. So something like, your message is too long. We don't handle 64-bit messages. Perfect. Okay, so let's go back to the spreadsheet and we can figure another thing. Well, the mask indicator, they have it's a constant, right? So we can see actually here how many bytes they are composed. So the mask indicator, it's always 4. So we can put it on a constant if you want. So I'll put here const mask key bytes length. It always is 4. Perfect. With it, we're gonna read this data, right? So here, const mask key will be what? Will be socket.read, and then we read this next 4 bytes. So you see, every time we call the read, we're gonna call how many bytes we will have. So as we are calling 4 here, we're gonna get all these 4 bytes that is mapped here. Okay. Well, if you look here, we can see after the mask indicator, we have actually all remaining bytes. So we're gonna use the payload length to get all the remaining bytes here. Okay. So let's get. With the message length, we know how many content we have to get. So I'll get the encoded sock.read, the message length. Just it. I'll put here I will put actually a console.log here. So we can put a breakpoint here. Oops, I'm gonna stop it. I'm gonna put the breakpoint on the console log and I will press F5 again. Okay, now our server is running, right? So we can go to the browser and update our web browser. So the encoded data is actually a buffer, right? But what if we try to get here this encoded to string and try to use like UTF-8? Whoa, we have some string here, right? This is actually the content from the client that we will have to decode. So using the mask, this mask is actually generated by the key the user are using for the communication. We can go and make the process reverse, okay? Going back to the docs, it's showing us how we can decode this message. Honestly, I read this text a few times and it didn't make much sense for me. Let's focus here on this part. Look that we have this magic number 4. This symbol is called mod and represents the rest of a division between two values. Assuming that the number is 2 mod 4, the rest of division will be 2. If the number is 3 mod 4, the rest of division will be 1. Still, I haven't understood what they are doing with this calculation. So I started reading back on my code again. Do you remember that in order to get the mask key, we had to read 4 bytes? As the mask key is an array containing only 4 positions, using index mod 4, just make sure we will always access available positions on the mask key array. It will only handle index positions from 0 to 3. Now, you may wonder what this circumflex symbol does. This was something new to me as well. I've seen this operator before, but I've never used it. This operator is called XOR, and it's part of the bitwise operators in JavaScript. Bitwise operators are used to performing math operations on binary numbers. In summary, imagine an array that contains all fields from a person. You have on the first position the name, on the second the age, and on the third the phone. As you saw the data coming when you're using the socket read function, all the information will be stored in a single position. The socket read function reads a number of the bytes, and each byte contains 8 bits of information. In other words, 8 spaces available to you store data. We could have all information stored in a single position of the array. The only difference here is that instead of strings or complex objects, they are represented as integers. That's where the bitwise operators such as OR, and, XOR, NOT, and others helps us. When we use them, they convert an integer representation to zeros and ones and perform operations to add or remove information. For example, imagine you want to change the phone that is part of a byte on your byte array by removing a digit. You could use a bitwise operator to change the zeros and ones representation to perform your changes. I know that's a lot of information, so let's go back to the VS Code so I'll show you it in practice. Well, now let's open the algorithm here and I'll just copy paste and I'm gonna change it, okay? Perfect. Well, I'm just gonna create a function here called function unmask. And we're gonna get the encoded data and the mask key. Okay, perfect. So this is the algorithm. I just copy from there. And actually, this encoded data is also a buffer in Node.js. So I'm gonna call it as encoded buffer. Okay, so you can search more about buffers and try researching, but that's it for now. Well, with it, I'll just get here const decoded, unmask, and encoded buffer, and the mask key. Perfect. And here, just a console.log, so we can debug it later. Perfect. Now we're gonna work on this one, right? So I think it's better to understand what those operators are doing behind the scenes, right? So let's make it work first, and then I'm gonna go through to each of these operators and you're gonna understand everything, okay? Well, right now I'm gonna just copy this buffer. So instead of working with strings, I'll call it like final buffer. And then I will create a copy from this buffer. So I'll just create another array of bytes for our case, so we can handle it without changing the encode data or making it dirty, right? Okay, with the final buffer in hands, what we should do? Well, exactly the same thing. So the final buffer in this position, we receive the encoded buffer here, right? So it will receive the encoded data, here the encoded length. I think it's better to use here like for in, right? Const index in encoded data, and we get the index like this. So I think it's better. Index, and then the mask will be our mask key, and the I will be the index, okay? So I here, it's index. Perfect. After it, we can return our final buffer. And that's it for now. Let's see if it works. Let's see if we can get any result differently here. Okay, I'm gonna save it. I'm gonna restart the server. I'm gonna open the debug console. I'll put here actually the breakpoint, and let's do the same process here. Just update it. Something wrong happened. It has only a getter. Well, maybe it's not an iterator. So let's go back to the for. So index equals 0. Index less than encoded buffer dot length. Oops. And index plus plus. Okay, let's start again and do the same process. And right now we have another buffer, right? So it's just an array of bytes in our case. But we can get here and use toString to see what goes there. Ooh, look how nice is it? Well, we got our data here. So nice. Right now, we have actually the message the client sent to us. Ooh, very nice, isn't it? Okay, with it, I will just get this data there. It will be like const received, to be decoded, to string, and as a good practice, I will use the encoding UTF-8. Perfect. I'm gonna parse it to JSON just to make sure the data is actually a valid JSON. And then I will just put here console.log message received, and then our data. And let's update it. And then we can see the result here. But look, if we update a few times here, we can see some troubles, right? Because we are not handling when the user disconnect, right? So we are keeping the connection open and trying to send messages or trying to read the socket. But we're gonna go through further later, okay? Well, let's understand what's going on this mask, okay? I think it's a good practice to understand before going on, otherwise we can get confused. Okay, so we know that this is for why? Because the mask key, right? So I'm gonna put it here as mask key length. So let's put it here. Because the mask key has only 4 bytes, we do index mode 4, which will return only the position 0, 1, 2, and 3, okay? So it's the index bits needed to decode the message, okay? So this comment here, what this means, so this is XOR. Well, XOR, let's understand in practice how it works, okay? Well, I was talking to you about binary codes, right? So let's try getting the binary code from a number. So here, imagine that I want to get 71, okay? So to parse this data to binary, I will have just to use toString and 2, which is the binary base here for us. Okay, I'm gonna keep both of them so we can understand XOR easily, okay? So it's equal to 1, 1, okay. Perfect. Let's get a second number. Now we're gonna assume that the second number is the mask key, okay? So imagine it's like 53. I'm not using random numbers here, just for you to understand. I actually use it from our payload, but we're gonna see some characters there. Okay, let's do the same for 53. Well, we have this string, and I'll do this same, okay? So, first thing we can see that we have different sizes, right? So, it should be like this. So, we should have more zeros right here. So, to make more as 8 bits byte, we're going to use the pad start. I'm going to use 8 because it's 8 bits, right? And I'm going to fill with zeros. And I'm going to do the same thing right down. Okay, let's paste it. Oh, now we have an additional 0 here. And for the 53, the same idea. Now we have 2 zeros, right? But why? Look now. Now we have a table, right? So we have these specific ones. So what the XOR means? XOR returns 1 if both are different, and return 0 if both are equal. Okay, so how do we do that? Let's make like an evaluation here. I will put right here so we can see later. So 0 0 equal, right? So equal 0, 0 1 1 because it's different, 1 0 different, 1 0 different, 0 0 equal, 1 1 equal, 0 1 different, and 1 1 equal, right? Okay, we have this number, but what does it mean? If you get here and do the same thing I did before, oops, parse int, we're gonna receive 114. It doesn't mean anything for you, right? However, here are the secret. I'm gonna put it here. We can use string dot from char code. So 114 is actually a char code for us. And then I'm gonna use that. I could put like 114 as well, but I'm gonna use parse int, the same idea. And then I will paste our code here. Okay, and I'm gonna use 2 because it will be back to the decimal. Okay, let's see how it's working in practice. Ooh, see, we have R, we have a letter here. So if you wanna use like other codes here, you can see other things, right? Like 100, I don't know. There are a lot of char codes. 100 is a D, 101 E, F, G, H, I, and so on. Perfect, perfect. But let's try doing the same way they are doing here. So let's go here. I will actually put it here, and I will use 71 XOR, right? 53. And then I'm gonna use the same idea we used here before to fill with zeros. Okay, so oops, if you run there, oops, pad start, it's missing toString, right? And then we can see that we have exactly the same binary code. Okay, but something I like doing here is just put some spaces, so when you are reviewing your code, you can reviewing better this thing. Okay, Nice, very nice. So here will be equal to this 0. And then if you do the same thing here, we're gonna see the code. I'm gonna put here so you can check this is the final code. I'll put in commas. Oh, just something to pay attention here. If it's not an integer, or actually if it's an integer, we're gonna see a different value, okay? So it must be a string, otherwise it changes. How nice is it? Well, I wanna create like a verbose log so we can check all these values coming, okay? So we're gonna reproduce all the data from the bottom to the top, okay? Well, first of all, I'm gonna make this piece of code here. So I'm gonna create first fill with 8 zeros. I'm gonna receive like the value, and I'm gonna use like t pad start. Then we have to parse it to binary, right? So const to binary, same idea. However, to use the toString, we have to fill it with the zeros, right? Oh, functional programming, very nice. Well, we're gonna use another one. It's like from binary to decimal. And then to make the process reverse, we use parse int, right? As we did here. And we call to binary. And then we can use the t and the radix to. Okay, and then we're gonna make the last step, which is from char code. Okay, I'm gonna copy this one. So const get char from binary. So we can debug it, or we can see on our logs it's going on. Okay, perfect. So to use the char code, it must be first a binary, right? But we have actually the decimal coming from here. So here we're gonna use from binary to decimal and t. Okay, let's see how it's working. I'll put here const logger, and I'll call it like decoded. Okay, and it will be char from binary in final buffer on index. I'll put right here just to see the logs. Console.log logger. Okay, I will restart our application. Check here on the debug console if it's running. Update our browser. Oh, see, we have all the decoded data here. Okay, Eric, but I didn't understand why you don't just put like toString here, right? Because we have all the values. Yeah, you're right, but I created all these functions so we can use for other purpose too, okay? So what I'm gonna do, I'm gonna unmask, make the whole algorithm here. I'll unmasking calc. So I'm gonna use the two binary we just made, okay? The two binary, we use the buffer index, our decoded data, right? All right, so as we have it here, we have to use the XOR, okay? And then I will put two binary again, but now it's on the masking, right? The same calculation we are doing there. So I will put it here. And then I will put equals to check whether the binary is. So the binary will be in the final buffer index, okay? And then you put a comma here. Well, as you may notice, this is just logs, okay? We are not performing anything new. We are just putting what we want here for our code. But with it, we can see some new logs there. I just restarted the application. I go to the browser and update it. Oh, buffer is not defined. Well, it's actually encoded buffer, right? Encoded buffer. Restart it again. Go to the browser. It's not open yet. Is it there? Nice. See how amazing is it? We see that this binary code, XOR, will be decoded to V. And we can see the whole message. Right? Look how amazing is it? Developer, professional, the numbers, and everything decoded here. Okay, I just made it so you can like perform your debugging on the binary code size. Oh, that's so amazing. Okay, but let's imagine we're gonna respond back to the customer, right? Because we already done that. We've actually used right here. What if I try to use socket right? Hello world. Let's see what the browser says. I'll go there. I'm gonna update. We should see something on the console, right? Well, we haven't seen anything here. But why? Because when we are sending back, we have to follow the protocol of the WebSocket. So let's implement it. Now that we are receiving those messages on the backend, we should reply back to the frontend, right? The specs works for both client and server, so we must create the data frame similarly of what we received on the backend. The difference is, by the specification, we don't need to mask the data from the backend to the frontend. Let's see it in practice. Okay, going back to our spreadsheet, we are working with 7 bits right now, okay? So we must create an object, a buffer, with the same idea. So the first byte should contain the opcode, the theme, the second byte, the mask indicator, the payload length, and so on. Okay, so how do we do that? Well, first I'm gonna create here a function called send message, and I'm gonna have this message and the socket. Okay, well, here I will just like use the socket right, just to make it like more readable, I would say. Okay, send message and the message. Let's create something here. Like my message will be JSON string file. I don't know, message, and I will put the message we just received. I think it's good. So the message we just received, we won't have here, right? Let's reply back after we have all the message here. So I'm gonna reply back with the data, and then I'm gonna put just at new date to ISO string. Perfect. And then we have the message, we have the socket, and then we go back to the send message, and here we're gonna use the message, right? But as I said, we cannot use just the object this way. We have to prepare the whole data frame so we can return to the user. So let's create it. Function prepare message. So we're gonna have the message. So I'm gonna call here data prepare message, passing the message and data. Okay. Perfect. And now we can work on this function. Okay, as we must keep working with binary codes and bytes and bits, let's make it our buffer, okay? I didn't go through the buffer on the Node.js side because it's another big concept and I don't want to confuse you later, okay? So let's get the message size so we can get the message length. Here I'm gonna call it message so we are not miss the variables, okay? So the message length will be just for this one. Why? Because we must choose whether it's 7 bits or 16 bits integer, right? Otherwise our browser will reject the messages. Okay, I'm gonna go first, create two functions here, two variables actually, data frame buffer and offset. I'm gonna explain this offset later, okay? So as we saw here, the first byte should contain the thing and the opcode. Otherwise, everything is 0 here, okay? So how do we do that? Well, first, we should know that 080 it's exactly the same of 128 as we saw before in binary, okay? So instead of writing, as we did here, 128, we could write like 0x and use the hexadecimal for this value as well, okay? Okay, perfect. So let's go back there on the prepare. Where's the prepare? Here. Okay, so with this in mind, we can use other kind of data as we want to, but I'm gonna do the same thing so you can understand what's going on, okay? So let's build here the first byte, and I'm gonna use another bitwise operator. As I said, the first bit is 0 or 0. I will use it, and I will use an optical text. So for this one, I'm gonna use 0x01. Oh my god, what this binary means? I'm gonna make another const here so you are not confused. Optical text, okay? So what this means is 1 bit in binary. Okay, it's like just one, just it. I think actually the VS Code translated for us, but just you can see other kind of data types you can use as well. Okay, so I'm gonna do this operation. Oh my god, what does it mean? Well, let's make the process as we did on the mask, so I think it's gonna worth it. Okay, well, first we can see how we can reach this value as well in JavaScript. So to reach this value, we can get 0x plus math apps. I just copied it from the Stack Overflow, okay? So toString 16, okay? Why 16? Because it's 16 bits. Okay, so let's check here. What does it mean? So as you can see, the 0x80 that we are using here is exactly the same 128. Just so you can go back and forth and try to understand what this binaries means, okay? Okay, here, so you can remember, it's single frame plus text, right? So this means it's a single frame, and this means we are going to send a text, a UTF-8 text, okay? Perfect. So, first of all, if the message size is less than equal to 7 bits integer marker, which is the 125, that is the specification sent to us, right? If you look at the complete edition here, you can see 125. It's a constant we use on the protocol. Perfect. Look how amazing is it. We're gonna make, first, we're gonna get these bytes on an array. So I'm gonna put just an array with 1 byte. And then our data frame buffer will receive a new buffer from the bytes we already have, and I'm gonna concat the data with the message size, okay? Why are we gonna do this? Because the whole buffer should contain the message size as well. I will comment it later so it won't be confused. Here I will do the same thing, else throw new error, message too long, body. Okay, because we are gonna work on this one later. Okay, right now we create a buffer, which is our byte array with the first byte, just the data we need for the specification. Then we send the payload size. And now we're gonna fill it with other things as well. Well, let's just go back here to the specification and let's go to the unmask, because remember I said, when you're talking from the backend to the client, you don't need to be masked. So in this case, I'm using the unmasked. So right now, the first byte should contain the opcode and the fin. So the fin, we just say if it's like a final message, and the opcode is either text or not. Okay, on the first position, we actually put the mask indicator, but if it's not masked, we don't need to change this value. So it'd be 0 by default. And then we can pass the payload length. So the payload length, we just put it, right? The payload length, we just concat it on the byte array on the end. Nice, nice. What should we do now? Well, now we should see how long is this buffer so we can create another to actually get the content we are trying to send to our data frame buffer, okay? So with it, we're gonna get the total length, will be our data frame buffer, dot byte length, and then I'm gonna send with the message size because we're gonna envelope, right? We're gonna wrap everything and then send to our final user. Okay, so right now we must create a new buffer with this new big size, and then we should concat our message, okay? So I'm gonna create a new function here called concat, and then it will receive the buffer list, right? And then the total length. And then look how amazing is it. From now on, we're gonna have the data frame response from our concat. So the list will be the data framer and then the message, right? Why this message? Because this message is actually a buffer. Nice. And then the total length. Perfect. After it, I will return the data frame response, and then we can keep working on our concat function, okay? Well, here will be very straightforward. First, I will create a new target. I will allocate a buffer. So I will actually allocate unsafe with total length, okay? So I'm just creating an empty buffer with this size. So imagine it's like 10 characters on the message. So we have a buffer with 10 empty spaces so we can use it. And then I'm gonna go through our list, okay? So it will be buffer of buffer list. Perfect. Every time we update this target, we should expand it, right? We should say, oh, where I will put this new buffer. So I will concat both of them. So I'm gonna create here, let offset equals 0, okay? And then I will call target set, and I will put our buffer and the offset, okay? So imagine we are trying to handle the data framer, right? The data frame will have two positions. The first one is the first byte. The second one is the message size, right? So in this set on the length 0, we're gonna have all the data frame we have, okay? On the other offset we have, the other iteration, we're gonna have all the content of the buffer of the message. So we're just concatenating this data. So offset plus equal buffer dot length. And then we just return it, okay? Target. So we are just merging both buffers here. Well, do you think this is enough? Ooh, let's see how it goes. So we called our concat, we pass all the buffers we have, and we are returning the data frame response. So on the prepare message, we are actually preparing it, and we have the data frame I'm gonna put here so we can understand what's going on. The data frame in here, and then we're gonna use this send message here, right? after we receive a message. So let's see how it goes. I'm gonna restart it. And here we can see it working. I'll go back to the client and now I will update it. Well, it seems it's not working. Ooh, something got wrong. So, message too long, buddy. So, oh my God, what we should do? Well, just to make sure it's the code itself, it's working. It's just the message was too long because we added properties, right? So I will just stringify this JSON. I'm gonna restart it and we should see some messages on the front end side. So I just updated. Ooh, very nice. Look how amazing is it. So we got the message, but actually what we need is on data, right? So let's go here on the index. When we have data on the message here, I'm just put here const message, message dot data, right? And then I will put the message here, and then I will just append it to the messages array that we have here. So inner HTML plus equal, I'll put like a BR. Front-enders, please don't kill me because of it. And then the message. Okay, let's see if it works. Ooh, right there we have data. So I'm gonna put here like a paragraph messages. Oh, very nice. So we have all the messages here. Perfect, but we must solve the problem of the 8 bits, right? So how do we solve this problem? First, we have to look after our data frame, and let's see for receiving mask data. Okay, let's go back to our server and let the object how it was, okay? A bigger object. I'm gonna restart it. And I want to see that problem again. So I started. And then we should see some error here, right? Right, so too long. Okay. Well, now we need to support bigger messages for both sending and receiving messages. But before moving on, if you've watched this video this far and haven't left your like yet, you know, right? And you should subscribe also for this channel so you're not gonna miss the contents I've been creating here. I left here on the video description a bunch of links for you to follow me after this video. There, I left also my training courses in Portuguese, and some of them I'm building for English-speaking people. In case you want to be notified about all the content I've produced, I invite you to join our Telegram channel. And don't forget to take a look at my website. I've been giving a lot of talks around the world, and I'm sure that you'll find something useful to study there. Going back to the content, that's why I made all of these sheets for different scenarios. We can debug and check what's needed on our data frame for each specific scenario. Well, we'll now change our WebSocket server to handle message size from 0 to 55K. This is also the maximum 16 integer bit size. And looking at our spreadsheet, we can check what changes on our payload. We can see here that for 16-bit integers, the payload length should come with the code 126. When the code is 126, our data will change a bit. Let's go back to our code and make some changes. Well, the first thing we must do is to change when we receive data, right? So we are here on the socket readable, and we can look at our spreadsheet. So we can go now to the max 16 bits, right? Perfect. So the first byte is exactly the same, so we are just consume it and throw away. The second byte will be the same thing as well, but then if the content length is 126, all the next 2 bytes will be actually the content length we need to know where is the data, okay? Then we have the mask key as we did before, and then all remaining data is just the data, right? Perfect. Okay, here we are not gonna change anything. okay? But here we have our indicator. So I will put here else if length indicator bits will be exactly our 16 bits integer marker. So if it's a 16 integers marker, we should read 2 bytes after it, right? Why? Because the content length is here, right? 2 after the payload, we have 2 bytes to read. Okay. So message length will be actually our socket.read more 2 bytes. Okay. And see how cool is it? As we are reading here, actually all of the next reads will be normalized because the specification said, oh, after you read this data, everything will keep the same and you don't have to worry. Okay. So here I will just read as uint 16-bit big Indian 0. Okay, this is another subject, so I won't go further because our class is huge. But I will just note here so you can search about what is kind of data. So big Indian 16-bit integer. Okay. So 16 integer, as I said, it's from 0 to 60k, okay? Or 2 power 16, so you have the 15k and actually what the specification said to us. Just this change, and let's try increasing our payload here, okay? So on our payload, I could do maybe twice or 3 times. Okay, so Eric, I will put some Jose da Silva, it's a very Brazilian name. Mary, I don't know, Santos. All developers, perfect. After it, I'm just gonna put here to check if we could get the data, right? So I'm gonna restart our server because we are just doing the receiving part. After it, we're gonna do actually the sender part as well. Okay, just check the debug console. It's running. Let's go back to the client, restart it, and let's check here. Okay, if you look at the data, well, it seems we got only one data. Well, on the index HTML, I should put here an array, right? I don't know why I put many objects. So I will close the brackets here. And now we have actually a JSON array. I'm gonna restart our server. I'll keep our endpoint there. And now we have, now we have the big one. And actually, just to check out, the length indicators is 126, which means it's a 16 bits integer. Nice. But if I just play it, we can see some problem here because the message is too long, right? Too long, buddy. Well, let's change it so we can send bigger messages as well. Well, going to the sender here on the prepare. Now we're gonna use this offset, okay? Well, let's put here else if the message size. If the message size is 16 integer, we should actually check if we reached the limit, right? So I will put here const maximum 16 bits integer, which is 2 power 16, right? It's from 0 to 65,536. Okay, I'll put here 16 bits integer. Okay, nice. Okay, let's go to the sender. Okay, so if it's less or equal our maximum integer for 16 bits, Then we're gonna recreate our object, right? Because we must pass more information there. Let's check the spreadsheet again. When we go sending, we are sending unmasked, right? So unmasked is just here. So we have to create the first byte as we did before, so it will keep it there. The masking indicator will keep there, and the payload length would change, right? So if the payload length or the content length is 126, we're gonna spend 2 more bytes to actually put the content length there, and then we can put all the remaining bytes, okay? So let's do it. So I'm gonna do the same thing. So target will be, we actually can put this offset, we can remove from here, and we can put it as 4, okay? Why 4? Because we are gonna put all the data we want there, okay? So we're gonna alloc. So target, as we did for concatenating data, buffer, alloc, unsafe, okay? And the offset. Offset. I'll put offset 4 bytes. So you know what I'm talking about, okay? All right, so on the first 2 bytes, what do you have there? On the first 2 bytes, we have the opcode and we have the payload length. On the next 2, we have just the content length, okay? Nice. Okay, so target on the first position will be the first byte, okay? The first byte that we just used before. It's just the same idea because it's a single frame, okay? It's the final message and it's a text. Perfect. Target on 1, what's gonna be? It's the 16 marker, right? 16 bits integer marker, so it's 126, okay? Well, as we won't put any marker here, because it's just 0, I'm gonna put here just so you know that you could put a mask indicator here. So I'll put here the pipe 0x0. So just to know the mask, okay? Just to know you can put a mask if you want, but you have to follow actually the specification to put this mask, but this is just detail, okay? All right, after it, we're gonna write on the next 2 buffers the message size. So I'm gonna write uint 16be, okay? And the value will be the message size and then 2 positions. Why? Because it's the 2 next bytes, right? Okay, I'll put here content length is 2 bytes. Perfect. Then we have actually our data frame buffer will be our target, okay? I will comment here so you can understand what's going on, okay? We're gonna alloc 4 bytes, okay? On the first position will be our 0x0. So in the first position, the number that will be there will be actually this sum, right? So we're gonna have 128 here, and when we pass the opcode, it will turn out as 129, okay? So if you wanna look what is going on there, we could say like +1. You can see the value as this, or as I did there, you can see like 001 pipe. So it's exactly the same thing, okay? So this is how we are doing there, but the binary code changes, right? So if you're gonna look after the binary code here, we could go to string 2, and then you can see here, okay? Just for you to take a look at the difference, remove the 8, the last digit will change only. Can you see? Perfect. The first position will have this binary code, okay? So what does it mean? Is 0x81. That is the fin code plus opcode, okay? Oh, nice. On the first position, what we have there? We have the marker, right? And the payload length. Well, here we're gonna have 126, right? Which is our payload marker, length marker, and it could be the mask indicator, right? But we are not using any mask, so we are indicator. So I'm gonna put here +0. I'm gonna put here +1, so you can remember at your house what's going on, okay? And I'm gonna remove this because it's can more confuse than help. Okay. The third position, well, the next two will be the message size, right? So it will start from 0 here, so content length, and 3 will be actually our, I would say, 171 content length. Actually, we can debug it to see what's going on there, but I think it's almost this, okay? And then from 4 to all of them, it's all remaining bytes, okay? Of the content or of the message. Actually, I will put here the message itself, so you know where is the message, okay? So we did all of the preparations here, and now it's missing just the 4th position, right? But don't you remember? Oh, we did it, right? We have the concat here. So with this change, it should work. Let's see in practice. So I'm gonna restart it. I actually gonna put a breakpoint here. So just you can change the values here. And I'm gonna update our client. Let's see if, okay. So here we have the message length. Oh, this is the, actually here is the readable. So play it. And here is actually the center, right? So the message center here is 309. So the content length here, actually we can check the target, see how amazing is it. So the 3rd position got 113, right? Because it's binary, so I put it here. It's different than it's just split it in 2 bytes. Perfect. I'm gonna play it and check if it's working. So message received, and whoa, we got everything we wanted here. Oh, very nice. Okay, just to finish our class finally, we can save this one, go to the index.html, and we can put it like a set interval. Each second, we're gonna send this message, right? Okay, and I'm gonna put it, let's close this, const interval ID, and I'm gonna close this connection, set timeout, after maybe 5 seconds, okay? Clean interval. Okay, well, let's see how our browser will work. So now we have the messages, now we have the real-time connection going there. Clear interval, oh, it's missing an R. It's clear interval. Wow, we are receiving a lot of messages here. And after a few seconds, we stop receiving messages, right? Very nice, isn't it? Congratulations on being so patient. I hope you were able to finish all the examples and make your WebSocket app work from scratch using JavaScript with no libraries. This application will need more and more features, right? We just implemented a few features, but it could give you some ideas and learnings about how to handle binary data in JavaScript and how this amazing web protocol works behind the scenes. If you want to go further, I would suggest that you try increasing the message size limit to 64 bits and try implementing the functions of ping and pong from the specification. Try also communicating data frames as fragments. In our examples, we only consume data from complete messages, but on the WebSocket protocol, you can also read pieces of data from a single request. You can try implementing authentication and rooms in case you want to create web chats, and implement the error handling for disconnected users in both back and front-end apps, and try making a load test to check how your application is handling a bunch of users simultaneously. I would say this was one of the most advanced content I've ever built. So I hope you like it. Tell me here on the comments what you find about it. Ufa, I hope you find this experiment useful, and don't forget to check the content in English playlist here on the channel. I've been building a lot of new content and I'm sure you're gonna like it. Comment below what you wanna see in the next videos, and please send this video to all people at your work, your friends, and your study groups that I'm sure it can inspire them as well. I hope this content has exceeded your expectations. Subscribe to this channel so you can be notified about all new content I publish here. I'm Erick Wendel, and I'll see you on the next video.